Cool. All right. So yesterday or last time, Tuesday, we talked about absolute value functions. We know how the function works already, right? It was one of our sort of standard function types. We looked at transformations. We know how to handle all that. Mostly we're focusing in then on solving equations and solving inequalities that have some kind or that involve some kind of absolute value. I haven't looked at that stuff yet. If you need a copy of the notes for 2.4, there's some up here. So mostly focusing on solving equations and inequalities, some application stuff as well, and the homework especially. But the idea is basically this: the absolute value tells us about a distance from zero, right? It's a measure of a number in terms of size, basically. So we don't care about the sign. That means that if we're solving an equation, we have to kind of reverse that idea, right? The way I would interpret this is that something that I don't know yet, right? I'm calling X. Its absolute value, so its size or its distance from zero is 3. If you're exactly 3 away from zero, then either 3 to the left or 3 to the right, which puts you at 3 or -3. So basically, we get to kind of take the equation and sort of split it up into 2, right? It's kind of a branching thing. And then this one, there's nothing else to do. We're done. But in general, there I might have, once I get to this point, I might have some other stuff to do to sort of finish solving, right? Oh, yeah, and I wrote a little sort of rundown, like get the absolute value by itself so that I can, think about it, right? Again, that's going to be kind of a general thing that we do with solving anything is kind of isolate the messy part first. Then think about the absolute value, break it down. Again, that's this like distance interpretation thing. And then if there's stuff to finish, then go ahead and finish it. The one exception to that is if we're comparing to a negative number. Because we use non-negative numbers to talk about distance, if I compare to a negative number, which would look something like this, that's saying that the distance or the absolute value is -2. Well, no, it's not, because when we talk about absolute value, we mean the non-negative version, right? The positive measure of how far away you are. This has no solution. Right, so that's the one time that we don't split things up. Now, nothing stops you from doing that, right? If I split this up and try to solve it the way I would other things, nothing stops me from writing that down. Like, you probably don't hear the sirens of the math police coming to arrest me or anything. Like, you can write this down. You can find numbers that look like solutions that just don't mean anything, right? Yeah, okay. The math police tend to work on a delayed, kind of system. Like they come for you later. So we have to, once we get the absolute value kind of alone by itself, right? We need to pause and think for a minute. I'm comparing to a negative number. That means I don't have anything to work out here. There's no solution. But that's a thing that I have to, catch for myself, right? Or be kind of, thinking about it enough to notice that, because, this is a thing that you've probably experienced. I have too, where, you're solving something, you're working a problem out, you get 2 or 3 steps in, and then like, that's your whole world. And you just want to push the things from over here to over there and move stuff around, right? And you kind of stop thinking about what's going on. This is a place where we kind of have to, in the middle, like force ourselves to just pause for a second and notice what's going on around us. So just be aware of that. It's not the only time that kind of thing's going to happen. Okay, and then I asked you to go home and do a couple of these, and you did. So let's talk about a couple of them. What do we need to do first in number 4? Add 3. Add 3, because before I can do anything else, before I can think about what the absolute value does or how to solve it, I need to have it alone on one side of the equation, because if it's not, then things don't work the way I might think they should, right? So I'm going to add 3 to both sides first. so that I get that absolute value term by itself. And now I can start to think about what that tells me, right? Now it's the absolute value of something, and I don't really even care what yet, but the absolute value of something is 1, which means the distance from 0 is 1. If you're 1 away from 0, where can you be? -1 or +1. So at this point, basically I can split this up. I can drop the absolute value as long as I consider, sort of both sides, 1 and -1. That kind of turns it from one problem into 2. But the 2 are very similar and, straightforward enough. You can work them out the same way. At no point up to this have I done anything with the stuff inside the absolute value. I didn't move anything into it. I didn't take anything out of it. I haven't touched it. I haven't really needed to even look at it, which is why I scribbled it out like this. If that helps you, great. If, cover it up with your thumb or something. Like, it doesn't matter what's in there yet. But now that I've gotten to this point where I've been able to sort of break it down, split it up, and drop the absolute value, now I can actually go look at the details and see what's left to do. Does that make sense? Okay, so solve these one at a time separately. The first one thing on the left, what should we do? Add 1. When you add 1, you get 2x is 0. 0 divided by 2 is 0, right? No cookies, but 2 friends. Like, no one gets any cookies, but at least you have friends, right? It's okay. So x is 0. And the other one, 2x is 2, so x is 1. So we get 2 solutions. They are 0 and 1. That's where those things are exactly the same. So it's just those 2 values. So we would just list them. Of course, you can check if you want. If you plug 0 back into the original thing, you'll see that that checks out, and so does 1. Okay. Everybody feel okay about that? Does anybody have any questions or anything? Okay. All right. What about 5, the inequality? You could turn whatever that is off. Thank you. Okay. Just so I don't think I'm losing my mind and, it's the voices talking to me again. So we're solving an inequality now, right? To solve an inequality, first we're going to solve the equation, right? So forget that it's an inequality. Just solve the equation first. This is, again, pretty much the way I'm always going to do inequalities. Solving equations is a little more concrete and stuff. So if you remember times where you've worked with inequalities before, I think somebody maybe even mentioned yesterday, like sometimes the sign flips, right? Well, because of that and because of some other stuff that I don't want to have to deal with, I'm just going to solve the equation so that I don't have to keep up with any of that kind of stuff. So 3x plus 2. We can go ahead and move the, I guess it wouldn't be a bad idea to do that first. Go ahead and move the 5 over. But instead of looking where it's greater than, I'm going to look at where it's equal to 7. So the absolute value of something, again, I don't really care what this is yet, right? But it's all by itself on one side of the equation. The absolute value is equal to 7. First of all, does that work? Does that make sense? Yeah, because we're comparing to a positive number, right? If this was negative, then I would just fail and say, well, it's either always or never. This is positive, so we're good to go. What do we do then? The absolute value is 7, then you're either at 7 or -7. So and then solve. Subtract 2, divide by 3. subtract 2, divide by 3. Okay, so we just found the 2 and only 2 values of x that would make those things exactly the same, right? The two sides of that equation the same. If you plug in -3 or if you plug in 5/3 to this, you get exactly 7 back. And that's the only 2 times that happens. And if we think about an absolute value graph, again, once we get the thing, kind of alone on one side of the equation, it's always a V-shaped graph that opens up like that. So it makes sense that there would be 2 solutions, because just about anywhere, if it's, like legal or valid at all, just about anywhere, there are going to be 2 places where it happens, right? Okay, we just found them. Here's 7, happens at -3, happens at 5/3. So graphically, like that's what's going on, right? The thing looks something like this. I'm not real worried about, exactly the shape, exactly where this vertex point ends up, whatever. I just want to have kind of a rough idea, like mental picture of what's going on. We still need to solve the inequality. What I'm going to do to solve the inequality, again, I'm just going to draw like a number line basically for the x-axis to keep things organized. And I'm going to mark on that the 2 points that we just found, -3 and 5/3. So here's -3, here's 5/3. If that x-axis is representing like the domain of this function, right? It's an absolute value function. It's defined everywhere, right? All real numbers be the domain for that thing. So what this does then is tell me that there are 2 places where something interesting happens, at -3 and at 5/3. These are exactly the thing on the left, the function is exactly the same as the thing I'm comparing to, right? The 7. What I need to figure out then is where is it not equal everywhere else, but in which way, right? Because I'm trying to answer where is this greater than or equal to 7. I know where it's equal to, now I want to figure out where it's greater than. So there are 3 pieces, right? 3 intervals. And what we need to decide on each of those intervals is, would that inequality, that statement that we're trying to check, be true or false, right? It's not in the middle, it's not equal because we just figured that out. What we need to do is check those 3 intervals then and figure out, okay, which way is it unequal here? If looking at the graph or thinking about the graph works for you, cool, that's great. Absolute value 3x plus 2, that's this. Greater than, above 7, that's this. So on this piece of the graph to the left of -3, is the absolute value bigger than 7? Does the graph of the absolute value, the V-shaped thing, does it sit higher than 7? Yeah, here it is, right? Okay, so that would be greater than here and less than here because it's below, and then greater than again out here because it's above again. If the thinking about it graphically part isn't, clicking for you, or you don't like it as much, and later we'll do the same kind of stuff with graphs that are a little more complicated where it's harder to like just say, oh, it's like this. Then another way we can do this that's a little more, concrete or feels a little more like you're, doing something, right, is by just picking some test points. So take anything to the left of -3. What I want to do is figure out if that inequality is true or false. So I'm going to take -5, I'm going to plug it into this and just check, yes or no, true or false, right? So the absolute value of 3 times -5 plus 2, -15, so -13. So 13. Is 13 greater than or equal to 7? Yeah. So that inequality is true then. So that interval where that inequality is true is going to be part of our solution set then. right? It's true. It works there. It's going to be part of the solution. I think yesterday I used check marks, like whatever works for you for, organizing stuff. I just want to keep track somehow of what happens on each piece. And then just do that 2 more times. Between -3 and 5/3, well, zero's in there. If I plug 0 in, I get 2. Is 2 greater than or equal to 7? No. That piece is out then. It doesn't work there. All right, the inequality is false. And then something bigger than 5/3. About how big is 5/3? Around 2? Yeah. If you're not sure, you have a calculator and you can check. If you're still not sure, the thing that's important here is that the thing I plug in and test from out here has to be bigger than 5/3, right? That's the only thing that matters. If I accidentally pick something that's not bigger than 5/3 because I'm not sure about how big 5/3 is, right? Then what I'm really doing is testing something in here, and what I get is an answer that's A, confusing, and like B, incorrect, right? So I need to make sure that I choose something bigger than 5/3. Well, 5 is definitely bigger than 5 divided by 3, right? Or 100 or 1,000,000 or whatever. Like, it doesn't matter. Just pick something that's definitely on that side of that point that you're testing, right? Because again, the arithmetic is just our way of like checking quickly-ish to decide if I want to keep each interval or not. I have to be actually testing stuff from that interval to get answers that make sense. So if x is 5, 3 times 5 plus 2 would be 17. Absolute value 17 is 17. Is that bigger than 7? Yes. So what is our solution set then to this inequality? Yep. And at the endpoints, brackets or parentheses? Okay, those are the options. Why? Yes, the inequality says or equal to, right? So it's allowed to be equal. And what happens at the endpoints? They're equal, right? Because that's where we found them in the first place. So this would be brackets on both of those ends then. Now, again, what this says is that if you take any x value from this set, from either of those intervals, and plug it in here, you're going to get something that's true. If you take anything that's not in that set, which would be stuff in the middle here that's left out, it would not be true. Right, which is just writing in interval notation, describing all of what we saw here. We tested. Okay. Now, a couple of like disclaimers. You don't have to write stuff the same way I write stuff. You do have to do things in a way that is, sort of like organized and, actually does what you're claiming to do, which is solving the inequality, and that I can understand because I have to grade it, right? Doesn't have to look just like mine. This is how I'm always going to do inequalities, because you can always do inequalities like this, right? I don't have to have, this isn't special to absolute value stuff. So in 3 weeks or something, when we do quadratic inequalities, I'm gonna do the same thing because the same thing still works. In 2 months, when we do exponential inequality, I'm gonna do the same thing because the same thing still works, right? So there aren't any like special tricks that only work in this one case or whatever, which is why I'm gonna do it this way. But again, if you have some other, system that works for you or whatever, then go ahead. If you're not sure if what you're doing is really doing what you need to be doing, like if you're actually checking everything, if you're actually, doing something in a way that makes sense and, would earn credit, then, come talk to me or ask. So again, inequalities, first solve the equation, because the equations are a little more like concrete, straightforward, right? Like they don't lie to you. There's not like little stuff I got to remember, like, oh shoot, I got to flip the inequality when I do this thing, right? That doesn't happen with equations. And then solve the inequality. Again, this is kind of by brute force, right? Like there's three intervals. Okay, let's find out what happens on them. But it's also, you know, you can do it in the like pretty procedural, like processy kind of way, right? Okay, does anybody have any questions or comments or whatever? You feel okay-ish about that? Okay. Obviously, you'll get, you know, plenty of practice in homework. There are a couple more here. We're going to go ahead and move on right now, but there are a couple more here that you should try if you haven't already. And my solutions are in Blackboard now. They weren't until this morning, but they are now. So you can work through those and check stuff and whatever. Again, tomorrow is, you know, free play. Just let's make sure we know stuff so we can do more than or talk about it more than if we need to. Okay, cool. All right, so our next section, 2.5, our next new material, covers something called piecewise functions. Piecewise functions are a thing that right now, looking at, well, okay, the stuff that's on the screen right now is not that scary. When I hand this to you and you look at what's on it, you might think, ooh, that was kind of scary, Dr. Jones. But then by the time we're done today, you're like, man, that's easy points. That's no big deal at all. So all this is really going to do is kind of reinforce and check some of our understanding and how we work with function notation. A piecewise function is just something, you know, if we think of a function as like a rule for explaining how X and Y relate to each other, right? How one affects the other one, how they change together. Then a piecewise function is just that same idea. It's still a function, only now I have to make a decision first about like when to do what, right? So it's just a function that's broken up into pieces, hence the name. Because for whatever reason, like the rule, the formula that you use, whatever, changes depending on where you are. So this is something that like we actually deal with pretty regularly in some stuff, especially any kind of like monthly bill kind of thing, right? Like my water bill or your phone bill or whatever, you pay this much. Think about like your data plan, right? You pay this much as long as you only use up to like 10 gigs of data. And if you go over that, then they charge you a little more, right? So like that's a piecewise function, because if I ask you, hey, how much is your, you know, cell phone bill? You say, well, you know, as long as I didn't use too much, it costs this much. But if I went over, then it's more, right? Maybe you don't pay your own phone bill, so you don't think about these things yet. But that's the idea, right? Tax brackets is another. If you don't pay your own phone bill, you certainly don't do your own income tax. But like that's another kind of example of the thing, right? How much you pay is based on how much you earn, right? Everyone's at least familiar with you know that far. That's pretty much the idea of a piecewise function. So for starters, here's a graph. Is that the graph of a function? What do we have to do to test a graph to see if it's a function? A vertical line test. Does this pass a vertical line test? Sure. Only place where things might get a little dicey would be right here, but this one's filled in, that one's not, right? Which means this one's included and that one's not. So there's still only 1 point right there at that vertical line at -3, right? Okay, so yes, it's a function. It passes a vertical line test, the usual thing, right? Okay, now look up some values. So find f of -4, find f of -3, etc. Okay, what's f of -4? 5? Because you go to -4, you find the function, and the y value is 5, right? What about -3? I mean, same idea, right? That's the x value. I go find the x value and I see what happens. There's a little bit of a weird thing at -3, right? If I look for the function, I see this, but I also see this. So what's f of -3? -1, because, take it. Yeah, that one's filled in, the other one's not, right? So at -1, if all I'm allowed to do is look straight up and down, I don't see the thing above, right? That open point, the hollow, that's just there for our like benefit so we can tell what happens nearby, but it's not actually at that value. So this would be -1, 0, 2, and 4. You can't find it. Again, if I look at 4, if I go stand at 4 and all I'm allowed to do is look straight up and straight down, right? That open point doesn't exist just under me at 4. I see it, over there, but not like the spot where I'm standing, right? If I'm trying to like, I don't know, stand on the graph or something, I'm just going to fall at 4 because there's nothing actually there. That hollow circle open point, that's there for our benefit. 3.99999 is fine. 4 is not. So f of 4 is undefined. It means there's like no answer to that question, but literally what's happening is that the function is not defined there because there's nothing telling me what the function does or how it behaves at 4. Nearby 4, yes. At 4, no. Okay. That's a piecewise function. Each of the individual chunks, the individual pieces are not that big a deal on their own, right? This is just a horizontal line. That's like y equals 5. But we took the horizontal line y equals 5, we chopped the ends off, and we just kept this little chunk. Same thing here. This is just a straight line. It's got, looks like the slope is 1, the y-intercept is 2, so like whatever. I could find that line if I need to. But again, it's not the whole thing. We chopped the ends off and just kept that little chunk of it. And then same thing here, right? So this is a piecewise defined function in 3 pieces, which again just means like, well, you look at a different piece based on where you are, right? And we did that in doing this evaluation. Here, I looked at this one. Here, I looked at this one. Here, I looked at this one. Here, I looked at, well, nothing, because nothing was defining it, right? The way that we write down a function like that, the symbolic version, looks something like this. And this is probably the thing that kind of looks the most intimidating. The graph, whatever, you've seen graphs, right? This probably looks a little bit intimidating, but let's just kind of break it down. Again, this is going to kind of test our function notation stuff a little bit. F of x, well, okay, so again, we're naming a function, we're calling it f, we're writing it down using an x as the symbol, right? That's the normal thing, right? That's all that is. Equals, okay. Big curly brace. What do curly braces do? Yeah, there's group things, right? It means this stuff goes together. So f of x equals not just one of these things, but all 3 of these things at the same time. Now I'm gonna see, let me just like draw a line down the middle here. So you see it says f of x equals 5, and then there's a comma. X plus 2, comma, -2x plus 5, comma. Sometimes you'll see that with like a semicolon. You might see it just say where, or just have a big space or something. But what it's doing is giving you the rule or the formula or the usual thing for the symbolic version of a function, right? How you actually do it. It's giving you that part. And then the comma separating or saying, it's this, where this happens, or when this happens, or whatever. This is telling you when to use each piece. So that first part's defining what the pieces look like. The second part is when to use each piece. And this one again is in 3 pieces. So it's, sort of 3 separate like chunks, right? 3 different sets of rules, 3 different formulas if you want. And then when, the instructions for like when you do that, right? This is by the way, this is this. Like that's the graph of the same function. So those are the same. Different representations of the same function. Okay, so take a minute and answer number 1 then. Keep in mind you already know 2 of those answers, but think about how you would get them from this rather than from the graph, right? So you know the answers to the first 2, but make sure you get the same thing using this. All right, so how do we use the, sorry. How do we use this to evaluate, to plug in, to find f of -4? That's an x value, right? So if that's the x value, the first question is, okay, which of these pieces do I use to plug in? The way you decide that, if I take -4 and plug it into those inequalities, one of them is going to be true, the other 2 are not. So is -4 between -5 and -3? Yeah. This works. Is -4 between -3 and 1? No. Is it between 1 and 4? No. Okay, well, that means I don't need to worry about any of this other stuff. I just look at the top line, basically, right? So I just decide, okay, which piece works, right? Which is the correct piece to use for this? Again, if you want to actually do that as writing out the inequality and saying, oh yeah, that works, then that's cool. Like do that, that's fine. Probably once you've, done it 2 or 3 times, you won't really need to write that out. If you do, that's fine. But I'm just looking for which of these 3 pieces does that land in? Well, it's this one. That means I use this, right? Okay. So f of -4 then is 5 because I take that as our y value, right? I'm using this piece. So the y value is 5. All right, what about 0? Which of these does 0 land in? Not between -5 and -3. It's not between 1 and 4. It's in here, right? 0 is between -3 and 1. If it helps you, I mean, I know the inequality thing, if you're not used to looking at those, that might be a little bit confusing. If it helps you to draw that out or something, right? -5, -3, 1, 4. That's basically what you're looking at, right? To decide which of these do I use? Well, 0 is right here. So I use that middle one and ignore everything else, right? Okay, so I'm going to, again, ignore that, and just look at this one. And then I plug 0 into that. So plugging 0 into that, f of 0 would be 0 plus 2, which is 2. Okay, and then what's f of 2? Where is 2? In between 1 and 4, right? For the purposes of the moment, the thing I care about is the 2 is between 1 and 4. So we use that third piece of the thing and then plug 2 in as normal, right? Replace x with 2. -4 plus 5 is 1. Okay, so we just decide first which piece to use and then do that. And again, you can tie that to, what your cell phone bill is going to cost, how much you're going to pay in taxes, how much you're going to pay in tuition, right? That's based on how many credit hours you're taking, right? So if you call the registrar's office or whoever and say like, hey, how much is my tuition? They're going to say, hey, how many credit hours are you taking? And then be able to answer, right? So it's the same idea, right? First, there's okay, which set of rules do I need to look at, and then do it. Okay, so here's another one. There's a function called g. Find each of those things. All right, a lot of y'all try really hard to be quiet, so I'm going to do the thing where I call on people, like apologies in advance. But Conan, tell me about part A. Which piece do we need to use?
X is
So that one. So plug in there then, right? X is -2. That puts us in that first piece, which is for everything less than -1. So we plug in there. So -2, or the opposite of -2 when we plug in, right? Which is, well, it becomes 2 then, -2, so 0. Okay, good, cool. All right, what about 0? Okay. Yep. That's fine. You don't have to try to read the inequalities. Which means g of 0 is 1. Good. Okay, and then the last one, 2. Somebody, I don't know. Kayla, what do you got?
That's the last one.
Uh-huh.
And it's negative.
2 is equal to 2, right? So the ones that land on the, like, where the things, are cut, where we switch from one piece to the other, we need to be like a little bit more careful with. Like 0 is definitely in between these two, lands right on the edge, but this is the one that says or equal to, so we take that one. Which means I plug 2 into this, and if I plug 2 into that, I get 2 times 2 minus 7, 4, so -3. Yeah, good, cool. Everybody good with that? Yeah, okay, that's pretty much all we're ever really gonna need to do. There's maybe like one in the homework that has you come up with the graph, right? So going from the symbolic version to the graph. Let's take a look at how to do that real quick. Basically, all we want to do is just kind of look at one thing at a time. So forget that second piece, that bottom line is even there. Just look at the top one. F of x equals -x. What does that look like? That, right? Y equals -x. That's a line with slope -1, so it's going down. Y-intercept is 0, so there you go, right? That's y equals -x. Only, what am I supposed to do with it? I don't use that all the time. I only use it when x is less than 0, right? So what do we do then? What does that look like?
Cut off the right side.
Yeah, cut off the right-hand side of it. It's not the whole thing. It's just this part there. Okay, well then do the same thing. Y equals x. That's a line like that. But I'm not supposed to use the whole thing. I'm supposed to use the right side. This one is greater than or equal to. So now I'm going to include the point. Notice that they happen to be at the same spot. So it's continuous, right? There's not a gap between them. They glue at the same point. So the less than or equal to doesn't quite matter as much. And then the whole function is just this whole thing then. Right? I did it as two separate pieces, but that's the function. It's both of them together. That's f. We have another name for that. What is it? The absolute value. It's the same thing as the absolute value. Well, this probably gives us a little more like insight into the piecewise thing and how that relationship works. If you give me a number, wait, let me give you a number. Take the absolute value of 5. 5. What do you do?
5 away from 0.
5 away from 0, you drop the absolute value part, right? What if I tell you take the absolute value of -5?
5.
5 because
It's 5 away from 0.
5 away from 0, but that one you have to think a little more, right? We've kind of internalized it, hopefully, but like there's a decision there. If I give you a positive number, all you do is drop the absolute value. If I give you a negative number, you flip the sign when you do that, right? That's all this says to do. If x is negative, take the opposite of x. If x is positive or 0, then just take x itself. Right? So an absolute value is already a piecewise defined function. We're just, we haven't been thinking about it that way, but it's doing the same thing because we, again, have like a decision to make it first. All right. One example of a sort of context type problem where this would come up. Read through that a couple times. Okay, so what's going on? Yeah. Say that one more time.
The more cupcakes you buy, the less money
the less each one costs, right? Yeah, okay. So if you buy 500, it's still gonna be more expensive, yeah. They get cheaper as you buy more, right? The bakery gives you a discount. So anybody worked like retail or food service or anything before? Yeah, so it's like, customer calls, you answer the phone, they're like, hey, how much does this cost? And you say, well, how many do you want, right? That's what's going on. I can't tell you how much it costs until I know how big an order you're placing because the pricing changes. So what I want you to do here, and this is going to be you finish it on your own and we'll talk about it tomorrow, but first write a function that models the price for this. How many different, like tiers are there here? You pay one amount up to 100, you get a discount for 100 to 200, and then you get a bigger discount beyond that, right? That means that your function has how many pieces? 3. 1, 2, 3. So I want you to write down then what that function would look like, right? Both the formula that would give you the total price and the boundaries for when you would use that rule, that version of it, that piece. And then once you've done that, B and C just basically use it to answer a couple of questions. Okay, so finish that, and then also do anything and everything you can in the 2.4 and 2.5 homework. Again, they're not due until Monday. I'm just saying you would be wise to do that. I've said my piece about things, so tomorrow we'll work some problems. I'll have some stuff for you, and we can do questions and whatever else you guys want to talk about. Y'all have a good day. I will see you tomorrow.